Hello everyone, in this video we are going to discuss about determinants. So let's look at the menu. Well, in the first instance we will show how to find the determinants of 2 by 2 given some matrices there, so you can see the matrices, and we will just efficiently compute the determinants of 2 by 2 of the 2 by 2 matrices. The second series of examples is to solve equations that involve determinants, but we will go there in a minute. So imagine that we have the determinant is like this. We have vertical lines and inside we have the elements. So A11 means that this element is in the first row, first column. A12 is in the first row and second column. A21 is in the second row and first column, and A22 is in the second row and second column. So when you compute the determinant, you just take the diagonals, you multiply the diagonals, and then you take the difference minus, you multiply the other elements on the other diagonal. So you have A11, A22 minus A21, A12. Let's start with the first example. So we need to compute the determinant of matrix. So determinant of A, we use vertical lines and we explicitly compute this determinant. So it's 3 times 2 minus 1 times 1, so it's 6 minus 1 is equal to 5. We go to the next one. Determinant of B, it's 3 times 1 and then minus 3 times 2, so it's 3 minus 6 minus 6 minus 3, so it's minus 3. Let's see the third one. So the determinant of C. We find again the determinant of the matrix C. It's a 2 by 2 matrix with real elements. So it's 5 times 3 minus 1 times 1. So it's 15 minus 1, 14. Let's go to the fourth one. The determinant of matrix D is equal to the determinant of 8, 2, 1, 1. So it's 8 times 1 minus 2 times 1. So it's 8 minus 2 is equal to 6. And let's go to the last one. Determinant of E. It's 3 times 1 minus 9 times 9, so it's 3 minus 81. This can be written as minus 81 minus 3 minus 78. So the first one, the determinant of A is 5, determinant of B minus 3, determinant of C 14, determinant of D is 6, and determinant of E is minus 78. This is the first series of the examples. Now let's go to the other part of the menu. Let's see, will it be more delicious this time? Let's solve these equations in the domain of real numbers. So we start with the first one. Everything flows naturally here. There is no traps. We just solve these equations that involve determinants, and that's it. So this is x squared minus 0 times 0, which this term vanishes. plus 3x plus 2 is equal to 0. The discriminant is 3 squared minus 4 times 2 times 1, 9 minus 8, so it's 1. We have two distinct real roots, so x1 is minus 3 plus square root of 1 over 2. So x1 is equal to minus 1. Let's compute the other root now. Minus 3 minus 1 over 2. So minus 4 over 2 equal to minus 2. So x2 is minus 2. We go to the next one. X squared 1 1 1, and we add the other determinants. Let's find these determinants. So x squared minus 1 plus x cubed minus 1 plus x minus 1 is equal to 0. So it is x cubed plus x squared plus x minus 3 is equal to 0. Here we can see evidently that if we replace x and if we put instead of x, if we put 1, so it's 1 plus 1 plus 1, 3, minus 3 is equal to 0, so it verifies the relation. Let's apply Horner's method to this polynomial. Let's write the coefficients of x cubed, which is 1, the coefficient of x squared is 1, coefficient of x to the power of 1 is 1, and the constant term minus 3. And our candidate is, the root is rho equal to 1. So we put the 1 down if in case that you have forgotten how to do the Horner's method. And then we multiply 1 times 1, 1. We sum up these two, so it's 2. 2 times 1, 2. 2 plus 1 is equal to 3. So we multiply 3 times 1 is 3, and this gives us 0. Minus 3 plus 3 is equal to 0. So now we can factorize this. So it's x minus 1 times x squared. We have a degree of 2, x to the power of 2, plus 2x plus 3 is equal to 0. So from here x minus 1 is equal to 0, so x is equal to 1. There is our root. Now x squared plus 2x plus 3 is equal to 0. So it is 2, the discriminant is 2 to the power of 2 minus 4 times 3 times 1. So it's 4 minus 12 minus 8. So it's negative. And I remind you that we solve these equations in the domain of real numbers. So we don't care about complex roots at the moment. Our only root is x equal to 1, and that's it. Now let's go to the third example. We have a product of two determinants, x squared 1, 1 and 1 times the other determinant equal to 0. What do we have to do? Find this determinant. It's x squared minus 1 times x squared minus 2 times 2 minus 4. This x squared minus 1 can be written as x minus 1 times x plus 1. And the other one, x minus 2 times x plus 2 is equal to 0. So x minus 1 is equal to 1. X minus 1 equals 0, x is equal to 1, or x plus 1 is equal to 0, x is equal to minus 1, or x minus 2 is equal to 0, so x is equal to 2. And the last case, x plus 2 is equal to 0, so x is equal to minus 2. And we have solved this equation. Now let's go to the penultimate equation to solve it. This is x squared minus 3x plus 2 is equal to 0. The discriminant is 9 minus 8, 1. It's positive. We have two distinct roots. Let's go. The first root will be 3 plus the square root of 1 over 2. So x1 is 4 over 2. x1 is equal to 2. And the other root is 3 minus 1 over 2. x2 is equal to 1. And this equation has also been solved. Last but not least, we have the problem E, which is this one. This is e to the x squared minus 3 times e to the x plus 2 is equal to 0. Now let's set omega to be e to the x. So we have omega squared minus 3 times omega plus 2 is equal to 0. The discriminant here is 3 squared minus 4 times 2, 9 minus 8 is equal to 1. So omega 1 is 3 plus 1 over 2. So omega 1 is equal to 2. And omega 2 is 3 minus 1 over 2. So it's 2 over 2 is equal to 1. So omega 2 is equal to 1. But we have said that omega is equal to e to the power of x. So e to the power of x is equal to omega 1 equal to 2. Let's take ln function on both sides. Ln e to the x equal ln 2. So x is equal to ln 2. This is my first root. My other root is ex is equal to omega 2 equal to 1. So ln e to the power of x is ln 1. So x2 is equal to 0. And of course, if you substitute x2 equal to 0, you see that this becomes e to the power of 0 is 1. 1 plus 2, 3. Minus 3 is equal to 0. And if you put the first root, ln 2, the natural logarithm of 2, then you have e to the ln 2, which is 2 squared 4, plus 2, 6, minus 6 equal to 0. And we have completed these two series of examples. So you can see that you can compute a determinant, a 2x2 determinant very smoothly. And in the next video, I'm going to show how to use Cramer's method to solve 2x2 linear systems. It's very popular to solve a linear system with Cramer's method, especially if you have 2x2 and 3x3 problems. And in Cramer's method, there are determinants involved, so this will be ideal to continue with further exposition of examples. Thank you very much for your attention and see you later. Until then, buenas tardes, amigos.